On screen, we have two particles, particle A and particle B. These two particles are going to collide. Particle A has mass ma. Particle B has mass mb. Before the collision, u indicates the initial velocity. ua indicates the initial velocity of A. ub, the initial velocity of B. Notice that I have used the term velocity and not speed. The velocity, unlike the speed, can adopt negative values. Let's take a look after the collision. V indicates the final velocity. The final velocity of A equals VA. The final velocity of B equals VB. We are going to use the principle of conservation of momentum equation, namely ma times ua plus mb times ub equals ma times va plus mb times vb. Examples. A and B are modeled as particles that are moving in the same direction. A has mass 2 kg and B has mass 1 kg. A has initial velocity 4 meters per second and B has initial velocity 2 meters per second. They collide, and after the collision, A moves with velocity 2 meters per second. Work out the final velocity of B. We use the equation stated on screen. We have the value ma equals 2, mb equals 1, ua equals 4, ub equals 2, va equals 2, and we are asked to work out the value vb. Let's substitute these values into the equation. There we go. 2 times 4 plus 1 times 2 equals 2 times 2 plus 1 times vb. We expand the brackets. 8 plus 2 equals 4 plus vb. vb equals 8 plus 2 minus 4. vb equals 6 meters per second. Let's take a look at another example. Two cars are modeled as particles moving along a frictionless surface. Car A is traveling at 20 meters per second. Car B traveling at 10 meters per second, and both are going in the same direction along the same line. Car A weighs 1,000 kilograms and car B weighs 1,500 kilograms. Car A does not see car B and crashes into it. After the collision, car A travels at 10 meters per second. Work out the speed of car B after the collision. Before the collision, we have this scenario. So here we have the value of the mass of A, 1,000, the value of the mass of B, 1,500, the initial velocity of A, 20, and the initial velocity of B, 10. We substitute these values into the left-hand side of the equation, giving us 1,000 times 20 plus 1,500 times 10. After the collision, we have these values. We substitute these values into the right-hand side of the equation, giving us 1,000 times 10 plus 1,500 times VB. We expand the brackets. We resolve. More. We get 15 VB equals 250, giving us the final result VB equals 16.7 meters per second. I have rounded this to 3 significant figures. In the real world, this value may not correspond to reality. We have many factors that intervene in this. We are modeling these cars as particles. In reality, in this case like this, there will be other factors such as there may be an explosion. It would alter the results. There may be friction. There may be resistance from the air, for instance. But it may have this value, possibly. Let's take a look at this scenario. In this scenario, both particles A and B are moving in the same direction. In other words, their velocities have the same sign. Imagine we have this scenario. Both particles are moving in different directions. Their velocity must have different signs. They're traveling along the same line and they're going towards each other. The velocity acting as a vectorial quantity, one of these velocities must have a negative value. Let's take a look at an example to illustrate this concept. Two particles A and B are moving along the same line in opposite directions. Before impact, A is moving at 5 meters per second and B is moving at 2. A has mass 3 kg and B has mass 2. The velocity of A after impact is 0 meters per second. Work out the velocity of B after impact. We have this scenario. So what do we do? Well, we know that UB has a velocity of 2, but it's in the opposite direction as the velocity of UA. Therefore, we are going to make the velocity of UB negative. We just substitute this value into the equation. We get 3 times 5 plus 2 times negative 2 equals 3 times 0 plus 2 VB. We resolve 15 minus 4 equals 2 VB. 11 equals 2 VB. VB equals 5.5 meters per second. Here we have some exercises. I recommend you pause the video now and try them.